Find a quadratic whose zeros are 3 and minus 5. So alpha 3, beta minus 5. Quadratic is x square minus sum plus product. So that is x square minus sum is 3 minus 5 x plus product of zeros. Product of zeros is 3 into minus 5. So we have x square minus 3 minus 5 is minus 2x, and here is minus 15. So you open the bracket, x square plus 2x minus 15. So this is exactly what is done here. Here the zeros, this is alpha, this is beta. Then you find the sum of the zeros, alpha plus beta. Next you find the product of the zeros, alpha into beta. And then you using the formula x square minus sum plus product. Find the product of the zeros of the quadratic. So f of x is x square minus 3. Let's just write it in standard form. Ax square plus bx plus c. This is the standard form. So it will be x square. X term is not there, so 0x minus 3. So on comparing, we have a equal to 1, b 0, c minus 3. Now the product of zeros is alpha into beta. So alpha into beta is c by a. C is minus 3 and A is 1. So the answer is minus 3. So the product of zeros, alpha beta, equal to minus 3. Here again, the given quadratic is x square minus 3. So when we write it in standard form, ax square plus bx plus c, we see a is 1, b is 0, c is minus 3. Then product of zeros is c by a, which is minus 3. The sum of the zeros and the product of the quadratic is minus 1 by 2 and minus 3. So the sum of the zeros means alpha plus beta is minus 1 by 2. And the product alpha beta is minus 3. Write the polynomial. So the polynomial will be x square minus alpha plus beta x plus alpha beta. And that would be x square minus 1 by 2x minus 3. So x square minus to minus is plus 1 by 2x minus 3. So this would be a quadratic. In the adjoining figure, the graph f of x is drawn. Find the number of zeros. The number of zeros will be the number of times the graph cuts the x-axis. So here it cuts at this point just at 1. So it will be, the answer will be only 1 point, hence it is exactly 1 0. So the answer here is, since it cuts at 1 point, it is 1 0. Verify that x equal to 3 is a 0 of the polynomial. So the polynomial here is p of x 2x cube minus 5x square minus 4x plus 3. We have to see is 3 the 0. So we do p of 3, which means wherever there is x, we will put 3. Here is x square, so we put 3 square, x 3 plus 3. We solve this. 3 cube 27, 3 square 9, minus 12 plus 3. So 2 into 27 is 54. This is minus 45. Minus 12 plus 3. If you work this out, p of 3 works out to be 0. Hence, therefore, we can say x equal to 3 is 0 of p of x. And that's exactly what is done here. This is your polynomial. By remainder theorem, p of 3, wherever there is x, they have put 3. And on working it out, you got the answer as 0. Hence, since the remainder is 0, we can say x equal to 3 is a 0 of the polynomial. Write a polynomial, the product and the sum of the zeros are given. So the product of the zeros alpha into beta is minus 9 by 2. The sum of the zeros alpha plus beta is minus 3 by 2. Now the polynomial you know is x square minus sum plus product, which is x square minus sum. See this is the sum. So a minus of minus 3 by 2x product. Here is a product. So that would be minus 9 by 2. So you have x square plus 3x by 2 minus 9 by 2. In the adjoining figure, the graph of the polynomial is shown. Write the number of zeros. So for the number of zeros, we have to see how many times the graph is cutting the x-axis. And here we see it cuts it only at this point, at one point. So it intersects the x-axis at one point. Hence it has only one zero. Here's a similar sum. Here again the graph of p of x is given. Find the number of zeros. So we have to see how many times it cuts the x-axis. Here 1, 2, 3, 4. So it cuts the x-axis at 4 points. It has 4 zeros since it cuts the x-axis at 4 points. If the sum of the zeros of the quadratic is equal to their product, find the value of k. So f of t equal to kt square plus 2t plus 3k. Now when we compare it with the standard, that is ax square plus bx plus c, a equal to k, b equal to 2, c equal to 3k. Now the condition given here is the sum of zeros, alpha plus beta, equal to product of zeros, alpha beta. Sum of zeros is minus b by a. Product of zeros, c by a. Now let's put our values. Minus b by a, so minus 2 over a is k, c is 3k, over a is k. So this cuts off. So you have minus 2 over k equal to 3, k equal to minus 2 by 3. So that's exactly what is given here. Here is given the quadratic. They said sum of zeros is product of zeros. You put your values, you get your answer. If minus 4 is a 0 of the polynomial, then find the value of k. So p of x equal to x square minus x minus 2k plus 2. Now minus 4 is a 0, so we have to find p of minus 4. So minus 4 the whole square minus, wherever there is x we put minus 4. So 2k plus 2. So p of minus 4 equal to minus 4 the whole square, 16 plus 4 minus 2k minus 2. Now since minus 4 is a 0, so p of minus 4 will be equal to 0. So 0 equal to, when you work this out, you get minus 2k plus 18. So 2k equal to 18, k equal to 18 by 2 equal to 9. Find the zeros of the polynomial. So here we have the polynomial x square minus 3x minus m plus 3. We will open the bracket. X square minus 3x, minus into plus is minus, so m square minus 3m. Now we're just going to rearrange. So we have x square. I will write here minus m square. I have only rearranged. I've written m square here and minus 3x here. Now this is x square minus m square, a square minus b square, a minus b, a plus b. In this I take minus 3 common out. So when I take minus 3 common out, what remains here is x plus m. Now here again I take x plus m common out. So we have x plus m common out. What remains inside, this I've taken out, this also is taken out. So what remains inside, x minus m minus 3. Now to find the zeros, I have to say x plus m equal to 0 or x minus m minus 3 equal to 0, which means x equal to minus m and here x equal to plus m plus 3. So the zeros of this polynomial are minus m and the other zero is plus m plus 3. Find the sum of the zeros of the quadratic. So the quadratic is x square plus 7x plus 10. We compare with the standard ax square plus bx plus c, a equal to 1, b plus 7, c equal to plus 10. And we have to find the sum of the zeros. So alpha plus beta equal to minus b by a, which is minus 7 and a is 1. So alpha plus beta equal to minus 7. And that's exactly what is done here. Here is a polynomial. We compare it with the standard polynomial ax square plus bx plus c and we get this, a equal to 1, b equal to 7, c equal to 10. So the sum of the zeros, alpha plus beta, is minus b by a. We put the values and you get your answer. Find the zeros of the polynomial. So here is a polynomial x square plus x minus p plus p. We open the bracket. So we have x square plus x, open the bracket, minus p square. I have not written this correctly. This should be 1 here. So I open the bracket, minus p square minus p. I rearrange here. So this is x square minus p square plus x minus p. I have only rearranged. Now a square minus b square, a minus b, a plus b. So a minus b, a plus b, and this is x minus b. Now I'll take x minus p common out. This x minus p from here, x minus p from here. So what remains now is, here is x minus p common out. What remains inside is x plus p plus 1. Now to find the polynomial, I only have to do x minus p equal to 0 or x plus p plus 1 equal to 0. If x minus p equal to 0, x equal to p, or x equal to minus p minus 1. So your zeros are p or minus p minus 1, not end. So these are the two zeros. P, we can take minus p common out, p plus 1. And that's exactly what they have done here in this. The 14th one, find a quadratic whose one zero is alpha and the product of the zeros is 0. So 1 0 is alpha. So 1 0 is minus 5. So alpha is minus 5. Product of zeros is 0. So let us find beta. So minus 5 into beta equal to 0. Beta is 0 over minus 5. Beta equal to 0. So I put beta equal to 0. Now to find the quadratic, we have x square minus alpha plus beta x, alpha beta. So x square minus alpha plus beta, the sum of the zeros, minus 5 plus 0, x, alpha beta we saw here is given as 0. So we will put it as 0. So x square minus 5x, so x square plus 5x is your answer. If alpha beta are the zeros, find the value of alpha raised to minus 1, beta raised to minus 1. So p of x, the polynomial, is x square plus 5x plus 5. Compare it with the standard ax square bx plus c, and you get a equal to 1, b equal to plus 5, c equal to plus 5. Then we find what is alpha plus beta. Alpha plus beta minus b by a, so minus of 5 by a, that is 1. Alpha beta c by a, which is c is 5 plus 1. We need to find the value of alpha minus 1 plus beta raised to minus 1. Means 1 by alpha plus 1 by beta. Take LCM, alpha beta. So this would be now here into beta, this would be into alpha, into alpha. So here you get beta plus alpha. Now beta plus alpha we know is minus 5. So here we put minus 5. Alpha beta is 5. So this is 5. We cancel, answer minus 1. And that's exactly what they've done here. Alpha plus beta is minus b by a. So alpha plus beta is minus 5 by a. A is 1. Alpha beta is 5. And then you put 1 by alpha plus 1 by beta. Take the LCM and work out.